Good to go.
All right, welcome everyone. Welcome to another Tech Academy Tech Talk. We have a really special guest, Chris Thompson's here to talk about MLOps, and they're going to talk about why they're important, what they are. They're also going to explain how they got into the field. So go for it, Chris. Thanks for being here so much.
Sure. Yeah, thanks for having me. So there's this new and emerging field. I wouldn't call it new, but it actually has a title now. It's called MLOps, or Machine Learning Operations. And that might ring a bell because you've heard of DevOps, and it draws a lot of its best practices from the DevOps world, but it is slightly different. And we're going to be going over kind of what the differences are, and what it's all about, and why we need it, and why it's desperately needed today. So the quote, so no machine learning model is valuable unless it's deployed to production. So that's a really important concept to understand, is you can go build models all day long, but in order to actually make it useful to anybody, you have to be able to put something, give it out to end users. And to tell end users that they need to feed an array of 64-bit floats to a machine learning model is not useful for end users. They just want to click a button and have things happen for them, right? And so we need ways to deploy models to those end users to make them useful. So that's kind of the idea of MLOps, is how do we get machine learning models into production, and how do we keep them healthy and make sure that they continue to function as we expect and meet our objectives that we've set for them. So we're going to start off asking, why MLOps? Why did this even come about? What were the challenges? What problems is this solving? We'll define what it actually is, what I do on a daily basis. What does an MLOps engineer, as we are now called, what do they do? We'll talk about components of MLOps. So talk about the various stages as well as technologies that are associated with those stages. There's been an explosion of companies bringing out new platforms and new software that aims to address a lot of these challenges. And then we'll kind of look at career outlook. I always like to look at the career outlook, because why would you do it if you can't do it for a living, right? Just for fun? I don't think so, right? So we'll look at how in demand it is, why it's in demand, and kind of what it'll look like in the future. All right, so starting off, why MLOps? Okay, well, when we start off, right, we have machine learning algorithms, right? And if you're not clear on what machine learning is defined by Wikipedia as, right, the study of computer algorithms that can improve automatically, and that is really the crux of it, right? So when you write an algorithm, right, in code yourself, that algorithm is set in stone, right? You've written it, it does the same thing, right? And in order to update it, you need to go in and update your algorithm, right? So if you're processing data a particular way, or you're making decisions in a particular way in your code, in order for it to make different decisions, you need to go in and manually code that in, right? Well, with the rise of machine learning, we've been able to take advantage of many years of experience from lots and lots of smart people, and it draws heavily from optimization, like linear algebra and that kind of stuff. And now we can actually, these algorithms have different algorithms in and of them, inside of them, right? That will update, they'll update themselves based on training data that you're feeding it, right? Without being explicitly programmed to do so. And that's when you hear training a machine learning algorithm, that's what it's doing, is it's kind of teaching itself the best way to do things, right? Based on a certain data set that it has received. Okay, and there's this really funny, I love this. If you don't know XKCD, you should definitely look up their comments. They're super funny, but this is a classic one. So this is your machine learning system. And he's like, yeah, I just pour data in this big pile of linear algebra. And you just get the answers on the other side. He's like, what if the answers are wrong? He's like, just stir the pot until you get stuff looking right? And that's what it feels like sometimes when you're building machine learning algorithms. Is all it is on the back end. And if you don't know linear algebra, no big deal. It's a lot of linear equations bundled together, right? That are making that are able to calculate a certain answer. And so this is oftentimes the joke, is that on the back end, it's really just linear algebra, and that's happening. And so it feels complex, but it actually is an old linear algebra stems from way back in the day, like the 40s, I think, or the 30s or something is when linear algebra really took off. So it's a very old concept, but applied in a new way. So in machine learning, when we're first talking about building a model, right, you start with with a goal. You need to define some sort of business objective. You don't just start coding an algorithm, which a lot of data science and machine learning engineers, people who get into data science, they're ready to go. They want to code an algorithm, they want to put it out there, and we pump the brakes and we say, all right, well, we need a goal first, right? Like, what's the objective? So you often receive that in the professional world from the business. The business will come to you and say, hey, we have this problem. Can you solve it? And you kind of sit there and you think about it, right? And you say, do you have this data? You collaborate, and you end up saying, okay, we think we have an idea. Move on to you access, understand, and clean data. And of course, if you followed anything with data science, you know this is the most time expensive, drawn out process. It's probably the longest part of the whole process is actually cleaning the data, getting it into a form that a model will accept, because you can't just feed raw data into a model and expect to get good results. There's a lot of cleaning and wrangling that happens in order to get the data into that. And data is very, very dirty in the real world. It is not Kaggle data sets. It's pretty nasty to deal with sometimes. So that can be a very long process. Then you move on to actually the part that everybody loves, which actually doesn't take as long as you might think, building the machine learning model. Okay, so you pick the model. There's many models to choose from, decision trees and neural nets, or even a logistic regression, whatever the case may be. But you pick your algorithm, your model, and then you train it on the data that you've cleaned, and then at the very end of all that, you deploy the model, right? So one thing we're going to come back to is that you never really know how well you can train your model. For those of you that are familiar with data science, and you have your test set, you run it on your test set, and you're like, oh, my accuracy or my recall or my F1 score is like super, super good. That means my model is amazing, right? Well, no, not exactly, right? We don't actually know for sure 100% how our model is going to do until it's in the real world. So once we deploy the model, that's when we actually get to know, hey, how did we actually do, right? We can get close and we can guess, but you really don't have the answer until it's in the real world. So that's where deploying is really, really important. And then you have this iterate step, right? Because that's not the end of it, right? And we'll talk about that more, which is part of MLOps, is addressing this iterate step, right? How do we iterate? How do we, the world is changing, right? Data changes, and the model needs to change with it, right? And so we need a way to detect that. We need a way to understand when that happens. And we need a way to easily, well, I shouldn't say easily, but painlessly get that model retrained and get it back out in the real world so it can start giving us what we want. And I'll give some examples of that. I know that's really high level, and we're gonna dig deeper, okay? So when you're first getting into machine learning, most machine learning classes teach you how to build models. Okay, you learn all the sklearn and TensorFlow or whatever, PyTorch or whatever you're using, right? Whatever your package is. And you come out thinking, I can build models, I'm a genius, I'm gonna go get a job, right? Well, it turns out, like I said, that building models is actually the smallest part of that entire process, the data science or machine learning process, right? That little box, and this is very classic, this is from a paper called Hidden Technical Debt in Machine Learning Systems that came out in like 2017 or something. And that paper talked about, okay, we're building models, but there's all this other stuff that goes along with supporting that model. It's not just a model, right? Like there's so much other stuff, feature engineering, process management, monitoring the model. Like, how do we do all of this? And this is where MLOps comes out of, right? Is like, okay, the data scientists, the machine learning engineers might build that model, and they'll do a lot of, many times, like the data wrangling, the data processing, but the rest of all of that stuff is very software engineer based, very DevOps based, right? And many data scientists, their talents are not in that space, and they need supporting teammates to do those types of activities in order for everyone to be successful, but for them to be successful, right? And to use their time in a way that's valuable to an organization. Okay, and so here we go. What percentage of your data scientist's time is spent just deploying models? Okay, we're not talking about anything else but just getting models out there for people to use, right? And 36% of respondents from the survey from Algorithmia said their data scientists spend 25% of their time just putting the model out there, right? Which shows you just how hard and how difficult this this process can be, right? And then it moves up from there. 36%, a quarter to half of their time is spent deploying models, right? And then so on and so forth, all the way up to 3/4 of their time, right? 75% of the time of a PhD physicist's time is spent doing a software engineer's job, right? Or a DevOps engineer's job, but not really, right? Because DevOps engineers know how to deploy software, but that doesn't mean they know how to do the machine learning aspect, because there is a certain background you have to have in machine learning to understand what goes into maintaining that model, retraining that model. You have to have a sense of how that works in order to do this stuff. So you couldn't just hand a model to a software engineer or a DevOps engineer and expect them to know what to do with it. This is a slightly different process and a slightly different beast that you're dealing with when we're talking machine learning. Okay, so that shows you, you know, how much time this process takes and how much and how important it is that you have supporting teammates to take care of that. Imagine freeing up 36% of your data scientist's time to actually work on different, better algorithms, right? Which is what they should be doing, right? So we're going to talk about 4 key reasons, right? 4 key reasons for MLOps. First reason, right? There's a lot of dependencies, right? And that's what we're kind of getting at here. A lot of dependencies in machine learning. And the data in the business are not static. And that's kind of the key difference between software deployments and machine learning deployments, right? The world is changing, right? I like to think of it as when you're writing software, you're writing the rules of the world, right? You're defining the state of things. When you put some software out there, you're telling users how to use your software, right? It's kind of the reverse when you're talking about machine learning. In machine learning, you're taking in the state of the world and telling them something about it, all right? But the world, that changes, right? And so there needs to be this constant communication, right, to ensure that the model in production aligns with the expectations that were originally set, the problem that you originally wanted to address, right? Because the problem statement might change too, right? Like once you get it out there, you realize, oh, that wasn't quite what we wanted to solve. And you need to iterate on that. So that's that iteration step. You have risk mitigation, okay? So that there's a couple of facets to that, right? So one, when you're deploying models, right, you want to make sure just they're performing, right? Like I said, the state of the world is always changing, so on and so forth. But a real large risk are things like big banks are using machine learning to, say, make loans, or are using it to detect fraud, or something to that effect. And if you get it wrong, right, if you're wrong on that stuff, that can have a real impact on people's lives. Like a very, you know what I mean? So you want to make sure that you are monitoring, gathering as much data as humanly possible to make sure that that doesn't happen, or it happens to as few people as possible. So MLOps addresses this risk mitigation, right? Like it helps to alleviate some of the risk involved with machine learning, because it's not perfect and it does change, and problems do pop up. A lot of problems. So they need to be acted on quickly when they do pop up, right? And so we can look at this nice chart, right, which is it's a risk matrix, Okay, and what we're looking at here is the impact from left to right, right? Is, if the impact is negligible, right, and the likelihood of a problem occurring is low, right? Like if it's negligible and it's unlikely the problem's going to occur, then the risk is low, right? Okay, fine. I don't need to really address that problem. Now, on the left, they say likelihood, think probability. On the top, think impact. As we move from left to right and bottom to top, notice how we get more into these yellow and orange colors, where it's going to have a moderate to significant impact on the business. And that can really affect many things, right? Not only people's lives, but the business itself, right? If customers start getting bad predictions, well, they're going other places, and that's costing real dollars to the organization. So this is another reason that you want to have eyes on every part of your machine learning pipeline, right? You don't just put a model out there and say we're geniuses and pop the champagne, right? That's the work's only beginning, right? Once that happens, all right? So, and in talking about people, that brings us to another thing, and this has become more and more of an issue that has popped up over, I would say I've heard more about it over the last 2 to 3 years than I ever did before that, right? And that is responsible AI. All right, and there's 2 aspects to responsible AI, and that's intentionality, which ensures that there's visibility on bias and accountability, on bias, right, in your data and in your model. Because the world, we have biases as human beings, right? So the data we collect oftentimes will reflect those biases that we've had. And you've probably heard many of the news stories that have come out about, say, like a CV system, a computer vision system that can't detect, say, like Black people very well or something like that, right? That's a huge problem, right? And again, affects people, affects organizations, and it's definitely something that we need to make sure that we're keeping in mind as we're building these models. I work in healthcare, and it is critical, right? You can think healthcare. It is critical that we get these things right, and that we are keeping our eyes on any bias that is, that is in our data that we're feeding these models, right? We're very aware of bias and accountability, right? So as data is going through, first of all, we want it to be collected responsibly, and that is a heavy topic, and I won't get into that. There's lots of nuances with that topic, but we want to make sure that we're getting our data responsibly. We want to make sure our data is reliable, from a reliable source, right? We don't want to be building models on data that's crap that's going to affect people's lives. Like, we need to make sure the data is quality data, right? So there's lots of, that's part of that, when you're finding your data, that initial step that I said takes a very long time, that's part of it. You need to check your data sources and make sure that you're getting everything correct, and make sure that you're, classic saying, garbage in, garbage out. You want to make sure you don't have garbage, right? And scale. So when we're talking machine learning, right, if you're just on your laptop and you're just messing around with, I don't know, whatever, a computer vision model, right? And you're like, hey, it can recognize this is my face. Like, that's cool, right? Like, and you don't need to scale that. But when we're talking about putting it out for millions of users, right, we need to figure out, how do we scale this model, right? Like, how do, when we're hosting a model, it's common that you use a server, a model server, right? And you need to be able to scale that model out, because at some point you get a bottleneck of requests coming in, right? So when that happens, you want to be able to scale out that model to handle more requests. That can be a really hard problem. That is very, very challenging, and probably one of the harder problems that I've solved was the scaling issue. And there's lots of cool technologies to solve that, but those are also very complicated. So scaling is a big problem, and not only scaling one model, but big companies like Zillow, or obviously Google, or any of those, the big tech companies, you're going to see they have millions of models, right? Or at least thousands of models sitting out in production, right? And so they need to monitor thousands of models. So, okay, monitor one model, Chris, that seems okay, but imagine monitoring 20,000, 100,000 models at once and needing to make sure all of those models are quality models and not losing and all of the stuff that we've talked about, right? That's a problem. That's what MLOps wants to solve, right? Is that a lot? I keep saying that, but all of this needs to be solved, right? And scaling is no less important than any of the other ones we've seen. So hopefully I've laid out, right, what we're getting at here when we talk about MLOps. And now let's talk about what is MLOps? Like, how do I do MLOps? Like, you still haven't told me, so I'm going to tell you right now. MLOps is a set of practices, right, that aims to deploy and maintain machine learning models in production. All right. So what we're talking about here is moving towards automation of all of this stuff. So automatically retraining a model when it goes stale, right? Monitoring, automatic alerts if anything's going wrong, and making sure that our systems are pushing us towards our business goal, our business objective that we've laid out. And you can see here this Venn diagram. This is a classic one. It's all over the internet. You'll find a bunch of them that look like this. Right? This is kind of the blend of data engineering, machine learning, and DevOps. It all blends together into MLOps, right? And you can, so any one of those is a really hard thing to do, right? DevOps or machine learning and data engineering by themselves, those are hard. When you mix them together, it multiplies, right? So you have to have this really unique background in order to do this discipline. You know, you usually start from something like data engineering or DevOps or machine learning and move in. You don't just start with all three and hope that you're going to be in MLOps, right? You have to have experience to understand like how these systems fit together and how all of this works. And so I'll talk about my background a little bit later and how I got into it. But for now, we'll concentrate on kind of defining what this is. So here's a picture from Google's website. I refer back to their kind of stages of MLOps quite frequently. And it's on Google Cloud's website, and it's called MLOps, Continuous Delivery and Automation Pipelines and Machine Learning by Google. And they kind of define these like stages of where organizations might be at in MLOps. I would say the majority, honestly, that I've seen and talked to are in this stage. Unless you're a very large company and you needed to solve this early on, a lot of companies are sitting right here at this stage. And in this stage, this is where we'll start. And there's a much more complex diagram later, which is why I wanted to show you this first before we get to the other one. Right? In this stage, you kind of have some data, right? And hopefully you can see my mouse. Yeah, you can. Okay, cool. So in this stage, you have data sitting here in like a SQL database or whatever, right? Like offline data. And you query the data and you get your data set, right, that you want. And then you kind of do these manual experimentation steps. So this is another part of MLOps that we'll get into. Experimentation is key, right? Enabling your data scientists to be able to experiment with ease is vital to moving your, to getting machine learning models out there as fast as possible, right? You want to make it easy on them, right? So you have these manual experimentation steps. And these manual experimentation steps, if you know data science, would be like a Jupyter notebook, right? So you bring your data in, and then you're in your Jupyter notebook, and you kind of like, split the data set and do all your things, right? This is all, so you do the data preparation, which is like splitting and standardizing all that stuff. You train your model, you click, model.train, right, in your Jupyter notebook, and it trains on your laptop, and then you evaluate, right? So you have your test set, and you're like, how'd I do, right? Once it looks good, then you take your model file, right, and you put it, they say model registry. Honestly, many times I just see the model embedded in software. Like they just take the model and they put it in the code base. And then they just load the model when the software gets fired up, right? There's like, oh, we need to make a prediction, load it up, sklearn load, and then that's kind of their serving, is just kind of, it's in the data, it's in the code base, and then whenever they need it, they just call dot predict on it, right? and that's their prediction service. So it's rare that I even see them with a model registry. A model registry is like a dedicated server, right? And by server, it could be like a Docker container. NVIDIA has some. We'll look at some examples of some later. You know, the models are usually stored there, and as requests are made, the requests are diverted, right, to a model server, and that model server often is attached to a model registry. The server will grab the model, make the prediction, send it back to you. So the server gives you a nice API interface to interact with models without you having to call like .predict, right, or .load. So, but nevertheless, this is kind of it. It's a very manual process in the beginning, right? When you're at kind of a stage 0, right? Okay, we can get models, we can put them out there kind of, but notice there's no monitoring, there's no, right? There's no iteration really. The iteration would be go back to offline data, get more data, and go back through manual steps, use the Jupyter notebook that we already made, right? And that's not scalable, and it's a very slow process. So without the monitoring, right? Let's talk about monitoring. What can go wrong? Like, what are we monitoring for exactly, right? And there's kind of two major things. There's many things, but these are two major things that are model related, right? Not infrastructure related. That's a whole other monitoring thing. But we'll concentrate on modeling. So when you're looking at models, what you're looking for, and I love this graphic. I found this in a Medium article. I've listed it here if you want to go read it. But we're talking about concept drift. So first one is concept drift, and what this is somehow, right, when you have inputs, your inputs are your X, your outputs are the thing you're predicting is your Y, you know, so somehow, well, the machine learning model, when it trains, it finds a relationship between those two things so that it can predict the Y based on the X inputs, right? Well, at some point, the relationship might change, right? So the model you have out there, you're still feeding it X inputs, but it starts giving you the wrong predictions, right? And a great example is this right here. So during the pandemic, housing prices have gone nuts, right? Globally, nationally and globally, housing prices are off the charts, okay? And so this little robot is our little AI friend, and it's taking in your X inputs, and it's predicting housing prices. But all of a sudden, it started getting them wrong, right? Because all of a sudden, what was happening in 2019 is, you know, the data, the way it was making predictions then, is not the same as the way it should make predictions now, right? And so this is concept drift. The relationship between your inputs and your outputs has changed. And you need to account for that, right? You need a way to monitor that change. And there's many different tools out there to do that. TensorFlow Extended offers some nice capabilities in that space of monitoring your inputs, and we'll look at what data drift next, but kind of monitoring this kind of thing. So you need to know if you're, for whatever you're monitoring for, right? Like if your outputs, if you start to get wonky outputs, right? You need to know that, and you need to have an event happen on that triggers either an alert to your engineers, or if you're very mature in your MLOps process, will trigger an automatic retraining of your model. Hey, this is wrong. We need to get another model out there stat, because the state of the world is different, right? And that's what you're looking for. So when I say the state of the world changes, this is one way it can change. Another way it can change is data drift. All right, so that's a change in the actual distribution of your input features. Okay, and another great one, this is also from that article. I love this little robot character. So before, pre-pandemic, right, we're making predictions. And we're saying everybody is making 5 transactions a day, right? They're pulling out cash from the ATM, we'll say. Very contrived example, but pulling out cash from the ATM 5 times a day. So we know that if they're doing 5 times, they're within the range of what we think they should be, right? Like, okay, cool. 5 transactions is within the appropriate range of what we expect them to be doing. But during the pandemic, everybody was flush with cash because we can't go anywhere. And we're like on Amazon, we're just like, clicking away like we're playing a video game, right? Like it was crazy, and everybody's buying all sorts of crap. right? Well, all of a sudden the machine learning model's like, oh, you're making like 7, 10, 15 transactions a day. This must be fraud, right? This is not correct, right? And so it is correct, right? But the model is not trained to understand that. And so this is another way the state of the world has changed. The distribution of your inputs is now different. So your mean was 5, but now it has shifted to 7, okay? But 7 before was an outlier, and therefore we alerted on that, whether we blocked the credit card or whatever the case may be, right? And that's a problem. We need to retrain on that. We need to know when that happens, right? Which means basically validating the data before it even enters the machine learning model. So what we're looking at is prior to the model, has the data changed? Because if it has, we need to retrain on that data to make sure that our model understands that that state is different. Because understand that a model, even though it's dynamic in the way that it can learn, it's frozen. We freeze the model when we put it into production. And that's kind of a key thing I didn't mention. The model is frozen when we put it out in production. It's not learning, sitting there learning stuff, right? And so we need to make sure that we're tracking concept drift and data drift. If that changes, trigger a retrain, right? Cool. And some other things to consider would be like, you know, when you're putting a model out there would be, is your model making batch or online predictions? So like sometimes people will just like get a bunch of, you know, photos and then they just upload it to something and then they wait and then it comes back, right? Well, that's a batch prediction, right? Because you're just giving it a bunch of stuff and you're just kind of waiting for it to give it to you back. Online predictions are in real time, right? So they're giving you, as you're doing something, right? They'll be giving you predictions based on some action that you're taking. Okay, so that model is taking streaming data and consistently giving feedback on that, right? And so people like Facebook or Google, right? They're taking in real time. They're doing a lot of online predictions at any given moment. And then where will your model be deployed, right? So, okay, you know, you can put it on a server, bare metal. That I've done that. That works fine. But like we talked about scale, we talked about end users. Where are your end users? Well, what if I'm on a cell phone, right? Like, can I put a model on a cell phone? Sure you can. Can I put a model in a browser? Sure you can. Like there's lots of different ways to deploy a model, right? So you need to understand what your objective is and what you're trying to achieve in terms of latency and all that to know where and how you can deploy your model. So that needs to be something you need to think about prior. And does the model need access to the internet, right? Some models, they don't need access to the internet. They're living on the edge, right? They're out on some device somewhere, right? And so if they need access to the internet, that's something else to take into consideration when you're doing a deployment. You won't be able to put it on a sensor out in the world, right? You'll actually have to have some sort of connectivity, right? So taking other things into consideration. And that's kind of with the MLOps, when you're thinking through your original problem, right? MLOps is not universal. It's not the same for every single problem. You have to be thinking through the entirety of what you're trying to solve in order to know what tools you're going to use in your process, okay? And that brings us to the components of MLOps, right? Like what do we use? What are the tools of the trade, right? So if you're a DevOps engineer, you have things like, you know, GitHub Actions and Jenkins, or if you're in the cloud, you have things like Cloud Build and you're using Terraform, you know, like all of these kind of DevOps type tools to make your job streamlined and automate software deployments or whatever the case may be, right? Doing CI/CD. And then, but in MLOps, right, we have our own tool set. And many of the things we use are sampled from DevOps, but many of the things we use are very, very specific to machine learning, right? So I wanted to just outline this. We're getting more complicated, right? So just to summarize where we started, right? So we need the business, which often includes, right, like someone from the business side, and then you need an SME, a subject matter expert, because the data scientists won't necessarily understand the business, right? So you need someone to who's the go-between between the data science team, right, the engineering teams, and the business side, just as you would in any software, right, field, right? And so, so on this side, right, when we're talking about feature engineering, data, all that stuff, you have data engineers, you have data scientists. Oftentimes, I've seen just data scientists. It's rare that I've seen like, you know, maybe one data engineer, right? Like they consider me a data engineer at my current job, but I'm doing like all the MLOps stuff, right? It's like data engineer, MLOps. Okay, so I'm not a dedicated data engineer necessarily, but so here we got what we talked about: data acquisition, right? Prepare the data, feature engineering, right? Features are things that you're feeding into your models, so that's prepping the data to be able to be accepted by the model, right? Going through experimentation, blah 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 blah, and that's a cycle that you go through until it's ready, right? You think the data's ready, and the model's ready, right? And the data scientists are in this too. And your SMEs, notice the SME is still here. All right, so then we go to a runtime environment, right? We prepare it for production. You have your software engineers, your data engineers, and your ML architects who sit right here. ML architect is a newer role. They need to understand like software architecture as well as machine learning very, very, very well, right? In order to build out these solutions. Then deployment and production, you have your data engineers and sort of your DevOps role, right? That's where you need to get your models out to production. And then you have that monitoring and feedback loop I was telling you about, where we're looking at concept drift and data drift, and we're looking to redeploy those if those start to go south on us. And data scientists will often be involved there too, because they're the ones who understand the models. So you see there's a lot of collaboration here between many, many different people. All right, and that's kind of like the ML, we call it the ML life cycle. And now I'm going to dump the more complex example on you, right? So we were at ground zero when everything was manual, but what happens when everything's automated? Well, you get this super sweet pipeline, right? And so what we have here is, this is entirely automated, besides obviously the experimentation and those types of things by the super pipeline, besides the experimentation, right? Like that's obviously still done by data scientists, and it is manual, but there's some automated things, right? So where do I want to start here? Let's start up here, where we go into data analysis, right? So we'll start at the feature store. So we have this feature store. What is the feature store? Well, remember when we pre-computed data and made our features, right? And well, those features, maybe they can be reused for other models. Right? Maybe they can help us in a future problem. And what ends up happening is you want to be able to store those because you don't want to recompute features, right? If you already have features from data, right, you should be able to reuse those for other models. And so you have what's called a feature store, and that's where you keep those. So this is data that's already been processed, features that have been processed, and are available for your data science team to reuse for future iterations of either the same model or different models. Right? And that allows for faster experimentation because you don't have to reinvent the wheel every time you want to experiment. You just go into your feature store, you say, hey, I need this, this, and this because I have this new project I'm working on. And you can get that model done much, much faster, right? Or get that experiment done, I should say, much, much faster, right? And so then you have this orchestrated experiment. Oftentimes you'll have a platform here, such as Kubeflow or MLflow, that's kind of orchestrating your experiments, does some model analysis, and all of that is not done for you, but it's simple, or it's streamlined. I should say simplified. None of this is simple. It's streamlined. Okay. So then you have your code that you did your experiment with, right? And what this enables to this orchestrated experiments and streamlined experimentation also enables data scientists to share, right? So if I have an experiment and my model, I say, oh, I'm getting this great F1 score. I want to share this with Joe Blow over here. All right. So you throw it over the wall to Joe Blow, and Joe Blow runs it on his laptop. Well, if you're using Kubeflow, right, you just run the Kubeflow experiment and it works the same, right? Or it should, right? Because you can see things and so on and so forth. So you should be able to run the same experiment and get the same results. So that allows for faster collaboration, right? And efficiency and validation. So once you say that's good, right, we go drop that into source code. You get your source repository, GitHub, Bitbucket, whatever. Then you have some automated tests that run right on that orchestrated experiment. and that says you're good to go, pumps out the packages, right? Sends it down to the CD pipeline for automatic deployment, right? Which is great. So it deploys. Now, the key too, right? When you're getting data in the real world, it's coming in raw, right? So you need to be able to compute that data and change it into things that work for your model, okay? But that means you need to freeze. You need to be processing the data the same way that you process the data when you train the model. So you need to be able to deploy your entire data processing pipeline to make sure that it will be the same, right? And that's a very, very difficult, long process to get that right. But nevertheless, when you get it right, it's automated, right? So real data coming in, blah, 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 right? Goes to your model prediction service, right? And you have a model registry, right? So, sorry, this is the training pipeline. So the data comes in, you train your model, goes up to the model registry, goes out as a trained model to your prediction service, and then predictions are coming in, right? Boom, 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 boom. People are getting predictions, things are going great. Oh no, performance monitoring, right? We have concept drift, time to retrain, right? There is a trigger, right? That's key, automated trigger. I lost my trigger. Automated trigger, right? And that triggers the whole process again, right? Now, maybe the trigger just goes here, right? And we just say retrain with the data, the new data that we've been collecting, and now we have a new model that understands the state of the world, and now we're getting good. We're good again, right? Our performance monitoring is working, everything's hunky-dory again, right? And this process might repeat, right? Okay. I know that's a lot, but that's what it looks like if it's done correctly, or I should say, when it's more mature, right? When you're mature in your MLOps, this is what should be happening, right? Now, are your data scientists involved anywhere down here? Maybe at the validation steps, and maybe in this performance monitoring, just to check to make sure their models are doing what they think they're supposed to be doing, because they understand the data the best. They're the ones who worked on it. But overall, you should have alerting and different things like that set up to where they only look when they need to look, right? Like when something is anomalous. Okay. All right, so what I wanted to bring in was, I found this nice template from, I'm gonna totally butcher this, Henrik Skogstrom. Okay, hopefully that's right. But anyway, he came out with a blog post, MLOps stack, and came out with this MLOps stack template, right? Where you can kind of fill in, these are kind of the building blocks of a proper MLOps deployment, I guess would be the right word for it, but just ecosystem. There, that's a good one. All right, MLOps ecosystem, right? Your tech stack. Okay, so you need something for experimentation, something for your code repository, a metadata store, right? Metadata store tracks model metrics, data provenance, and data lineage, right? Knowing what data your model was trained on, all that kind of stuff. Metadata store, very important. That's how we know if our model that we're putting out is better than the model that was out there before, right? We need to know that. We don't want to put out a worse model, right? Well, where do we get that stuff? We get it from this. So these are all machine learning. This is from the Linux Foundation. This is their AI and Data Foundation Interactive Landscape. I love this. Okay. Let's zoom in a little bit. I'll get that bigger for you guys. There we go. All right. So you can find all of your different things you need here, right? And we'll zoom through this super quick. So for platforms, right, you have things like Kubeflow and MLflow and many of the other offerings that are around here are actually packaged up in things like MLflow and Kubeflow and or can integrate with those types of things. So these aren't all like you use them separately, right? Yeah. I'll drop that right now. Let me drop. I'm gonna put this in chat so people can get a closer look. Bam. Okay, there you go. So it's an interactive, and you can click on any one of these, and it will take you to the website for that particular offering. Okay, so we have platforms, MLOps. They say ZenML is the only thing, but I feel like I don't know, divvying out platform and MLOps. Like I don't know if those two things are mutually exclusive. But anyway, I didn't design this. But you have your frameworks, right? You have your libraries, machine learning libraries. PyTorch, Lightning, Fast AI. So on and on and on and on, right? For any scenario, for anything you're looking for. right? And these are all open source. So anyone can go in and begin to use them. Of course, many of them have enterprise offerings. And yeah, I'll share the slides after the presentation. And so, you know, your databases, you know, all the way down. I'm not going to go obviously through all of this. You can take a look on your own. But when you're looking to fill in tools, right? If you're looking for a specific tool, this is a great place to start looking. Okay? I often refer to this grouping here. This is probably the best I've seen. Notice we have inference down here, so you can think model prediction, right? So you have KF serving, you have the inference server, which is also has a model repository, right? So not all of these things are mutually exclusive. They come packaged together many times. Anyway, so definitely take a look at that when you're interested in filling in this MLOps stack template, okay? So real quick, your time check, cool, we're looking good. So let's look at the career outlook, right? Like, okay, this seems pretty important, right? Like, is it lucrative? Like, do I want to do it? I would say yeah. So my journey in, right? I've given a talk on this. You can watch the video on the Tech Academy YouTube channel. But real quick overview: I came out of University of Oregon in 2016. I was an economics graduate. I was doing a lot of time series analysis, not really like even understanding really coding, right, or programming or tech or anything. Ended up being a stay-at-home dad for 2 years, saw data science, thought it was going to revolutionize economics, and decided to, yeah, thank you. That was like 2015 that my kid was born. So he's like 6 now, but yeah, I appreciate it. So stay-at-home dad, and I was just like, well, I'll just ramp up, right? So I learned Python, I learned data science, I took a program at UCSD, came out of there, was going to a lot of meetups and stuff. TensorFlow came out in 2016, that was crazy. And then I did an internship at Mansus.ai, which is a local startup doing some machine learning for organizations. Ended up getting hired on full time. COVID hit, had to leave. Went to Pearson Publishing. Worked in their research and development department for a while, helping them do automated essay scoring. A lot of crazy smart people were like doing MLOps work in the research department. And then I currently work at Radiology Partners, which is like the largest radiology practice in the US. And we're doing a lot of cool stuff around helping radiologists and streamlining their workflows. And it's really nice to be able to do good things in the world, you know, like always look to do good. That's my philosophy in the tech space, because it's easy to do bad. So it pays a lot, but anyway. So that's where I'm at now. So that was kind of my journey into MLOps, and I just kind of like I fell into it. Like it wasn't even when I worked at Mansus, they were just like, here's like 2 servers, here's 2 GPUs. We need to put a deep learning model out there, so go do that, right? And my background was like statistics and like math and like, anyway, that was a crazy year, but we did it, and I lived to tell the tale. And it was very fun. It's a very fun field to be in, doing this kind of machine learning, being adjacent to just really smart people and being able to just be involved in a lot of cool projects. It's just been a real privilege, and I feel very lucky, very, very lucky. So, so some random stats. We always like to throw statistics out there, right? Let's just get these stats, and I have cited my sources, right? So these are real stats that I did not make up. Maybe they made them up, I don't know. So COVID-19 is driving investment in AI. 86% of organizations agree that the pandemic has or will cause their organization to invest in new AI initiatives. Initially, companies were like, we're ditching AI, it's too expensive, let's just do what we always did, right? But then they realized, oh crap, we need to automate a lot of stuff because our employees are no longer in the office. And all of a sudden they had all these new problems, right, that they wanted to get some automation on. And all of a sudden there was kind of this like, there's this sway one way where they held back and they were like, oh no, but then they dove head first. And there's been so much innovation in AI over the last couple of years as a result of COVID and just the nature of the world, right, the changing dynamics of how we work and live. So that's really important, right? As a person, as coming from a place of like economics and always thinking about like data and probably, you know, statistics and stuff, I always look for trends, right? So this trend is very interesting, right? So that could trigger you to think, well, I'm gonna go be a data scientist. But you and 90% of the rest of the world are also thinking the same thing, right? What I've always tried to do and what I do in investing and all sorts of other things, think of the adjacent thing. Think of the thing that's going to grow with the thing that's growing quickly, right? Don't jump into the main thing because there's too much competition there. Think of the thing that's going to support the main thing because you're going to drive up just as much as they are, right? And that's why I think MLOps is a really lucrative field, right? Because it's going to grow just as much as AI is going to grow. And AI doesn't look like it's slowing down anytime soon, right? ML AI, right? So in our latest survey, cloud architects came in at top 27%. So notice this, right? So cloud architects came in at the top, and this is for demand for positions, right? So cloud architects were the top, right, at 27%, followed by machine learning engineers, software engineers, and then data scientists. Okay, so notice the data scientists are at the bottom of that stack. Okay, all these other roles are vital, right? There's lots of people who do data science now, right? Because it was just a popular thing. It's the sexiest job of 2018, right? But there's all these other people that surround data science that data scientists need in order to do what they do. And so again, that's that adjacent thinking. Like, how can I be adjacent? How can I ride the coattails of AI to the top, you know? So consider that, right? Always be looking for those types of trends. And machine learning engineer is the best job of 2019, right? A machine learning engineer does a lot of these types of things, right? But notice that in 2019, 344% growth, average base salary 146. I'll tell you right now though, the cloud architects, they're about 146 too. So take that with a grain of salt. All right, and the biggest skills gaps were ML modelers and data scientists, right? But also notice this, that was 52%, but look at what's at 49%. Just understanding business use cases, just having a general understanding of how we can apply this stuff, right? So that's just as necessary, right? They're missing that almost just as much as they're just missing data scientists. So if you come in with this kind of like skill set of engineering side, maybe not so much a data scientist, but you understand how to apply data science and you understand where it can help, well, you just filled that 49% gap. That's really in demand, right? That's a in-demand skill, okay? So, and then data engineering. Data engineering is blowing up. I highly recommend data engineering. It's such a cool, fun field, and it's growing real fast right now for obvious reasons. I won't go into how much data is being pulled in per day, right, by Google and so forth. All right, so final thoughts. I know we're right up against time. So, number one, think MLOps, reason for it, degradation, right? We know that models need to be retrained. We need to monitor those models to make sure they do not get stale. And we need to be looking both on the front end of the model, right, for that concept drift, data drift, on the back end, right, or in the model really, for that concept drift, right? We want to make sure our predictions are still correct based on our assumptions that we made prior to deploying our model. All right, number two, way of thinking. It's not just like I'm an MLOps engineer. MLOps is a way of thinking about deploying models, because you can do it just ad hoc and just throw a model out there and hope that it works, and then, oh no, it's broken, and then scramble to fix it, right? But just like DevOps, MLOps is like a change in thinking about how you productionalize ML, right? So think that this is like a change in your thinking, not so much just like an occupation, right? And step three, or final thought three, I guess, each organization must take the time to evaluate where they're at and what their needs are before deciding on a tech stack, and even if MLOps is applicable to them. Because if they have like one model, right, do you really want to divert like all your engineering power to creating all this cool MLOps infrastructure around that? Like, maybe if you expect to put hundreds of models out later, or you expect that there's going to be more models coming down the pipe. But if you have one model, and that's your model, like, maybe you don't need all this fanciness, right? You can get by at like at that base stage or maybe one step above that, right? So be evaluating before you just grab the coolest, best new thing, right? And I recommend that for all of tech, right? Always think like, what's the easiest way I can do this first? Don't add complexity unnecessarily, all right? And with that, hopefully I described MLOps fairly and completely, but that's about the crux of it.
Awesome. Thank you so much on that talk. That was so informative. Any questions from anyone on this? And also, if you can't think of any right now, I can leave Chris's. I think LinkedIn is a great way to contact you, right?
Yeah, definitely.
So let me put that in the chat box so you can contact Chris in case you can think of a question. But also, we are recording this talk. So you can definitely go ahead and check it out on our YouTube page. It's probably going to be posted later today. There's Chris's LinkedIn. And then I can also put in the Tech Talk playlist in there again. Here is that. If you go check that playlist, Chris's previous talks are also posted on there. So very, very cool talks. But also for next week, we do have Dr. Brand coming in to talk about algorithms and the importance of them. So go ahead and check that out also. But thank you so much, Chris, for being here. We really appreciate it. And thank you, everyone, for showing up. But
let me jump in, answer one question that I saw. So when I say adjacent, right? What I mean is like think a parallel, right? A parallel occupation. So maybe there's overlap. I mean, there has to be, right? Inherently, because it's kind of like. But what I mean is something that's going to grow alongside that main path, right? Because sometimes, right? Think investing, right? Okay, you can invest in something like Apple, right? But if Apple's going to put out a bunch of, if they just put in an order for a bunch of chips, or say they decided to start pulling from a particular chip manufacturer, right? Maybe you invest in that chip manufacturer because they're going to grow just as much as Apple's going to grow, right? So when I say occupation, think occupations that surround that main occupation, because it's not a perfect analogy, but like, it'll grow, right? In parallel with that occupation. So in this case, AI, ML, right? Yeah. MLOps will grow as ML grows, right? But there's not as much competition. So the probability of you getting a job in that space is much, much higher, right? And of course, once you're in, you can always move around. There's always room to move all over the place, right? So.
Awesome, thank you. Yeah, sorry, Sherry, I didn't see your question in there. Also, I think people were asking for your slides. I'm sure if you guys get in contact with him over LinkedIn, he'll be able to help you out with that. But again, thank you so much, Chris, for being here. Thanks, everyone, for showing up. I hope everyone has an awesome weekend. Hope to see you next week. Thank you.
Bye. Thanks, everybody.
Bye, Chris. Thanks so much. I think like you can just contact him on LinkedIn and he'll share that with you. I'm not exactly sure what the URL is. But if you can't get in contact with him, let me know and I can help out.